Okay, this is going to be the second lesson in Algebra 2 for stats. We're going to pick up where we left off with the normal curve. Last class, we talked about the normal curve, this being the mean, and my one standard deviation, 2, 3, and then the negative ones. And there's my percent of my information, 68%, 95, 99.7. Okay, so that was the end of the last lesson. So we're going to come back to this, and what we're going to do is we're going to find the various probabilities. Okay, your calculator gives you the probability, and I'm going to show you how to do that in Desmos in a little bit. If they ask for the percentage, what we take is the probability times 100. If they ask for the number of people or items, we take the probability and multiply by the number of people or items. Okay? Now, let's talk about this. Let's say we have SAT scores. Okay? All right? All right, and they say, all right, what is the probability? We're finding all the probabilities that something's greater than 1,200. Okay? Now, here's what we have to understand what greater means. Okay? Greater means I would go to the right. So what this is going to be is positive infinity going that way. Okay? Now, let me show you how you do this. Real easy. Okay? You go to functions. Okay? You find the thing, you scroll down till you find the thing that says normal dist for normal distribution. Okay? Now, we'll get to later if it's a standard normal, but if they give us a mean of 1,000 and a standard deviation of 200, okay, so they're telling us put the mean first. So 1,000, comma, standard deviation of 200. We're going to click cumulative probability, okay? So what we have to understand is, am I going to the right? Well, I'm going greater. So what I'm going to do is I'm going to put my 1,200 in, okay? All right. Oh, whoops, that should have been 1,000, sorry. Okay, so my probability is 0.159. Just write, go ahead and write 3 decimals. Okay, then it says, what's the probability it's greater than 900? Well, nothing's going to change. I'm just going to change that number to 900. That's 0.691. Okay, now it says, when will it be between 1,100 and 1,350? Well, what does that mean? 1,100, 1,350. Okay, this would be between. Okay, so what I want to do is I want to select inner because I'm getting the inner probability. Okay, your smaller number goes there, your bigger number goes here. Oops, that's too big. Okay, 1,350. Okay, all right, so what does it say? My probability is 0.268. Okay. Now, what is it going to be when it says less than 1,500? So what that means is it's going to go this way to negative infinity. All right? So what I'm going to do is I want to go left because it's going less. Okay? Less than 1,500. So I just replace this number with 1,500. 0.9994. I mean, that's what's it. 2 nines and a 4. Okay? Less than 1,050. Same left, I'm just going to go 1,050. Okay, 0.5999. Okay? Less than 700 or greater, okay, than 1,100. So what that means is I got this and I got this. Okay? Now, what I want to do is I want to say outer, okay? It's going to go less than 700. Greater than 1,100. So this is actually really easy. Okay, 0.375. Okay, so all you got to understand is what it's asking for. Between, okay, or inner. Okay, this is the outer one. Obviously, this is left. Okay, all right, and this is right for greater. Okay, so don't overcomplicate them. Those are the probabilities. Okay, now, how do we use them? Let's go through an actual problem. It says an airline finds that travel between 2 cities have a mean of 85 and a standard deviation of 7. What is the probability a flight will take longer than 95 minutes? Well, what does that mean? Longer means greater than to that side. Okay, so I'm gonna show you how to do this again. We go to functions, all we got to do is find the thing that says normal distribution. Normal dist, first one there. Okay, the mean is 85 with a standard deviation of 7. We're selecting the cumulative probability, and we're going to go right, because that's what we want to find, 95. It says 0.077. Now, I am done there because that is the probability. Okay, all right. Now it says what percentage of flights take place between 75 and 80 minutes, 95 minutes. So what I'm going to have here is I'm going to have this going on. Okay, so I got to find the inter. Okay, so 75, 95, just like your curve. It's almost real easy, 0.847. Now, if you notice, it says what percentage. So what I want to do is take that and multiply by 100. So really easy, just go to this next line and just multiply by 100. That's 84.7%. That's how many flights we'll take between that period of time. It says that if there are 200 flights to this city on a given month, how many flights are going to take less than 100 minutes? Well, what does less than 100 minutes mean? It means that we're going to do this way, less than or left. Okay, all right, 100, that's 0.984. Now, since there are 200 flights, what I want to do is I want to multiply by that. Okay, so 0.984 times 200 flights. There's about 196 flights are going to take less than 100 minutes, okay? Why is that important? Well, if there's like a rule that says, you know, you have to be less than a certain amount of time, you want to make sure you know what you're doing there, okay? All right, so we want to make sure, all right? All right. So I'm going to go to this one, okay? All right, we're going to go to the mortgage one, then we'll come back to the other one, okay? It says the mortgage statistics indicate the number of years a new homeowner will occupy a house before moving is normally distributed with a mean of 6.3, standard deviation of 2.3 years. It says find the probability they sell within 3 years. So what that means is they basically sell less than 3 years, okay? All right, so then what I want to do, let's go ahead, I'm going to show you one more time. You go to functions, you scroll down, you find normal distribution. Okay, it's basically telling me put the mean first, which will be 6.3, I believe. 6.3, comma, 2.3. Okay, all right, we'll do cumulative property. Okay, so I want to go left, so I want to go less than 3 years sold, 0.076. What percentage of homeowners will move, should be move, after 10 years, okay? Well, that means 10 later is to the right. So what I want to do is just change this to right and say 10, okay? 0.054, okay? And it says, if I have percentage, what I just want to do is multiply that by 100. 0.054 times 100. Okay, so that's 5.4%. Okay, if 5,000 mortgages sold, how many homeowners will move between 4 and 7 years? Okay, so 4, 7, it's this one, so that's just going to be the inner. 4, 7, so I got 0.4681. Okay, if there's 5,000 of those, I want to multiply by 5,000. 0.461 times 5,000. So about 2305. Okay, it says what is the probability they sell their home less than 5 years or greater than 8 years after buying? Okay, so 5, 8. So this is the split one. Okay, so I want to go outer. So less than 5, greater than 8, 0.1 or 0.516. Okay, all right, anybody have any questions on that? Probably not. Okay, so I want you guys to try this one with the SUVs, okay? Now, if they give you a normal distribution, here's what you have to understand. They're assuming the mean is 0 and the standard deviation is going to be 1. That's why they call it the standard normal curve. Okay, so it says, what is the probability a data value will fall above negative 0.95? So watch, what does above mean? Above would mean right, just like the other one. So what I want to do, I want to show you what I would do is I go to functions, scroll down to normal distribution. Okay, now they almost like prompt you. Well, if you're not given one, just use 0, 1. Okay, cumulative property. Okay, we want to the right of negative 0.95. That's 0.829. Okay, what percentage falls between negative 1 and 1? Okay, now you could know this, or because we're doing the inner, negative 1 and 1, 0.8683. And how do I find percentage? Multiply by 100. Okay? 68.3%. And if you go back to that first slide we did, that's what 68.3% is. Okay, so let's go back to our problem. All right. What probability is the z-score less than 2? Well, what does that mean? 2 left. Okay. All right, so I'm going to go left 2.977. Okay. What percentage will be greater than 1.5? 1.5 would be to the right. We're going right, 1.5. That's 0.067. And since it's percentage, I multiply by 100. Okay, so don't outthink yourself on these. Some of these are really this simple. 6.7%. Okay, all right. Let's do, I think I got one more or two more for you. I got one more. I just want to go back through that normal curve one more time. Okay, all right. So for that normal curve, if they just tell you, they start asking for probabilities with z-scores, they don't give you anything. What you do, okay, is you just use this function, scroll down, this. They don't give you one, just use these ones that they gave you, 0, 1, cumulative. All right, what is the probability to be less than 2.5? That would be this way. All right, so left. Okay, click on that, 2.5. 0.994. All right, oops, sorry, I put that in the wrong spot. 0.994. What is the percentage of z-scores greater than negative 1? Greater mean this way. So what I want to do is go right, negative 1, 0.841. Percentage means times that by 100. Okay, 84.1%. Okay, what is the probability the z-scores will be between negative 2 and 2? Now, once again, you can know this because that's what that basic probability is, but if you want to, you can just do this. Negative 2 to 2, 0.954, okay? All right, obviously you can find the percentage if you wanted to. And then this one, greater than negative 0.75. So that means to the right. To the right, greater than negative 0.75. 0.773, and then multiply by that by 100. That's going to be 77.3%. Okay? All right? And so you guys can go ahead and try this one. And that's the end of the second lesson.